Now for the outer convective heat transfer coefficient, so H index O, we do the same method than before. First we need to calculate the outer Reynolds number in order to know which kind of regime we have. This time it's easier because we already know the velocity of the hot fluid, and so the hydraulic diameter corresponds to the outer diameter of the pipe, and those properties are given in the exercise sheet. Then we can do the calculation, and we find about 1500 for this Reynolds number. This is still below 2000, so it means that we have a laminar flow once again. This time we don't have the same correlation than before, because we don't have the flow inside the pipe, we have a flow over a tube. So in this case you have a correlation that is given, heat transfer correlation, that relates the Nusselt number as a function of the Reynolds and of the Prandtl number. So the Reynolds was already calculated, the Prandtl number, that's thermophysics property of the fluid, and it's also given in the exercise sheet, and we find 18.8 for the outer Nusselt number. Then as the Nusselt number is a function of the outer heat transfer coefficient, we can calculate this convective heat transfer coefficient, and we find the same value, so 18.8 watts per square meter per Kelvin. And so we know this value. We can already note that this value is pretty low. It's much lower than the heat transfer coefficient we had on the inner side of the tube.